All right, welcome everyone to the June 3rd Arborist call. The agenda is the standard one we always use, a little welcome and meeting intro. And then if we have research and implementation status updates, we do those as needed. Those are primarily on ZBRD and Zcashd, the node implementations for Zcash. And then discussions are, usually we have a few items that we go over, but then we also have some open time as well to talk about protocol related issues. Today, the items that we had kind of pre-slotted were a discussion of ZIP 239, go over the remaining audit schedule that we have in detail with Audit and NCC, and then take a look at the Nu5 timeline again, and then a wrap up. So, and then we should have plenty of time in there for just kind of open discussion as well. Arborist calls, for those that might not know, are bi-weekly calls where protocol contributors get together to talk about upgrade timelines and process, engineering efforts, design and implementation of new features, and identify blockers and unresolved issues. The goal is to make Zcash core protocol development more accessible for a wider set of participants and provide transparency into what's going on at protocol level within Zcash. Anyone can participate. If you would like to present or you would like to suggest something to be discussed in depth, you can reach out to me directly, Stephen at electriccoin.co, and we'll be glad to kind of fit you in. We're doing these every 2 weeks now, so we've got a fair amount of flexibility in how quick we can get something scheduled. But anyway, research and implementation status updates. Anything from any update from ZBRD this week that you wanted to cover specifically?
We're still working on Nu5. We are this close to integrating pre-Nu5 chain history. We just need to work out why the hashes aren't quite working right. I'm sure it's something simple. Famous last words. And we're waiting on some Zcash changes for the rest of, so for the Orchard zip 244 and 221. And we're also waiting on the Orchard circuits in the Orchard crate. So yeah, we're pretty close to being ready on that side of things. Otherwise, we've mainly been doing network stack security fixes and fixes to some of the cryptography and the cryptographic tests. We've been doing some transaction checks as well, so making progress there.
Okay. All right. Very good. Yeah. On the Zcashd slide, and I think I neglected to include a placeholder slide. I mean, we've been largely working on Nu5 as well. Of course, that's all we've had time for. And making progress on a lot of the things Taylor mentioned, on the circuit code implementation of, finalizing the implementation for the various zips. And we've been working through the spec and the specification audits within CC and Audit, which largely went well. The team can provide more of an update, but it's mostly just kind of minor issues and typos that were have been identified so far. So that's all looking really good. We'll go over the detailed audit schedule in a second, but yeah. So the first thing, kind of generally on the topic is ZIP 239. So kind of wanted to open up. Let's discuss. There's a little bit of ongoing discussion. It's Zcash zips. The issued number, I believe, is 570. Which is the discussion for ZIP 239. So, Dara, I know you had identified, I think, the last comment I saw.
Do you want me to screen share the ZIP?
Absolutely. Yeah. Let me stop. Okay. Let me stop sharing. All right. You should be able to go ahead.
Yeah. Okay. Hope this doesn't crash. The video's frozen, but okay, that might work. Right, let's see if I can do this. I have so many windows open, bear with
I think Dara holds the record for most open tabs that I've seen.
Yeah, I've probably got about 200.
That's it.
Well, no, 200 windows, not 200 tabs.
Oh, Windows is a different.
Oh yeah, found it. Okay,
Each
so
window
we're
has
on-
200 tabs.
Mm,
pretty much.
exactly.
Okay, can you see that now?
Yes.
Okay, so the basic issue here is, so for Nu5, we have non-malleable transaction IDs that only commit to the affecting data of a transaction, not the witness data. So the distinction is, basically the affecting data defines the semantics of the transaction, and then the witness data just authorizes it and can't change what it means. So that means that you can have different serialized transactions with the same TXID. So it's another problem for transactions that are mined in blocks, because you can only have one transaction with a given TXID that is actually mined. But in the mempool, so each node will enforce that there's only one transaction with a given TXID, but they might have different witness data between different nodes. So what can potentially happen is if you only advertise transactions by their TXID, and say an adversary gives you a transaction that has the same TXID as my transaction, but invalid witness data, then you couldn't then cache that TXID was invalid, because that would block my transaction from getting through. So Bitcoin had this issue with SegWit, and so they weren't able to do the optimization of being able to cache TXIDs as invalid. So what they did 3 years later was to make a change to the peer-to-peer protocol so that you could use the witness TXID, WTXID, in inf messages and get data messages, and that solves the problem. So what ZIP 239 is doing is effectively making the same change immediately for Nu5. And WTXID for Zcash is, as defined here, it's the concatenation of the TXID and the authorizing data commitment. So that's the commitment to the witness data. So we've written this zip. The motivation section describes basically just what I've described to you now. There's a minor simplification because we don't need the WTXID relay, which was just, it was for backward compatibility. So Bitcoin nodes would only send inf and get data with this new type after they'd received a WTXID relay message. And we don't need to do that because we just use the protocol version to negotiate it. Otherwise, it's very similar to BIPs 339. There's one open issue. So if we just look at how the inf message is defined in Bitcoin, okay, so it's basically, it has a count of the number of transactions you're referring to by the hashes. And then for each element, you have an inv type, which can be message TX or message WTX, the new type that we're adding. And then you have the hash value, and that repeats for however many the count is. So the issue here is for Bitcoin, all of the hashes are 32 bytes. But for Zcash, these new WTX IDs are 64 bytes. So the concatenation of 2 hashes. And that's because our authorizing data doesn't commit to the TX IDs, so you need both. That actually has some advantages because it means that if you have one of these WTX IDs, then you also immediately have the TX ID. So it's useful actually. But then when you're trying to pass one of these inf messages, if you just have the count, then you then have to go through each entry to check its type in order to know how long this is, because there are no internal length fields here. So if you actually look at the code, both in Bitcoin and in Zcash, it currently assumes that these entries are fixed length, so that would need changing. And the alternative design that is just mentioned in zip 239 is that we could add new inf.w and get data w messages just for the version 5 and later transactions. So that's the only open issue. Does anyone have any opinion on how that should be resolved? It is possible to implement it just the way it's currently specified. It's just a little bit more complicated and inefficient.
I am in favor of redefining the messages to support the different, well, actually, at the least, I'm in favor of having different inv types. And having different inv types can have the expected lengths be encoded outside of the in-band attacker controlled messages themselves. So if the inv type is message WTX, you know that it always has to be 68 bytes, and for each item has to be 68 bytes. So we don't have to worry about having an inline length field being supplied in these messages at all. So there's that. I don't know if we need to redefine the messages to segregate the different types of data, but I don't have a well-informed opinion right now.
So if you think about how this would be passed, you read the count, then you have to read each message type individually and then increment the pointer by either 32 plus 4 or 64 plus 4 bytes.
Clarifying question: where did you get the view that it assumes fixed length right now?
Oh, that is in the Zcash code. Just a second.
Yeah, I'm looking at that, and I don't see it. I don't interpret it that way. Put it that way.
Bear with me. So it's in main.cpp, I think. Okay. That's this one. Okay, it's here.
Right. So what this is currently doing is, so we're reading a type and then we're reading a hash inside. Yeah. So it's reading a length, and it's reading it's invoking the serialization, the deserialization operation for cinv that many times.
Yeah. Yeah. And cinv is assumed to be fixed size.
It's not assumed by the vector logic. It's actually yeah. So when you said that, I thought it was like, oh, it's explicitly parsing like 40 bytes repeatedly and then parsing it. But if we actually look at the cinv message data class in protocol.h, it is parsing 2 fields, but we could potentially add yes, it's in protocol.h, and if you look for cinv, so you see it's pulling read write type, read write hash. We could add a if type blah in here, read second hash and reinterpret.
So the vector deserialization just repeatedly calls the element type deserialization, does that?
Yes.
Okay.
Okay. So
that doesn't quite work the way I thought it does.
Yeah. So the potential problem here, basically the behavior you want is that because at the point you get inf messages, you know the protocol version of the peer. So what we can do is if the peer's protocol version is the right type, is the right level, we can use that to know that the peer will only send us a type that matches the TXID inv message type.
We no longer pass the version into the serialization op though.
No, there's a way to there's wrapping code we can use to do that, but we can work around that basically. We can work around it on a case basis.
If it's not a problem, then we should just do it the way it's currently specified in 239.
Yeah, we can make it work relatively easily, I think. But yeah, because we know the peer versions, and then the moment the network upgrade goes out, any extra logic we'd have to add to make it trickiness to make it work, we can then remove. Yeah, so I don't have a concern there, and yeah.
It won't be a problem for Zebra either. We do currently assume fixed lengths exactly as Dara was describing. But we will just create an enum variant for the upgrade, and then we'll remove it after the upgrade. So it'll exist in the code for 3 or 4 months, and then it'll go away again.
Yep.
Okay.
Yeah, because obviously after the upgrade,
239.
Yeah, after the upgrade, we will still have old style TXIDs coming around because we still support v4 transactions.
Yes.
But it will be parsed by something that is explicitly, it has two potential states. It can, and then can contain 1 or 2 hash values at that point.
Yeah.
Yeah. In fact, actually, that's an interesting point. Do we, rather than setting it as a message, having just published it, rather than setting it as a, we have the type and then a hash, do we want to actually just make this a bit more general to be like, you can, if the upper bit of type is set, then the env message is 2 hashes?
So currently the value for the type is the same as message WTX in Bitcoin, and I did that deliberately so that there will be no clashes in future if we added anything else from Bitcoin.
Okay.
Sorry, I don't see that in Bitcoin. I see message WTX having the high bit set. Unless I'm reading the wrong protocol documentation.
This could have changed in. Hang on.
Let me link you to what I'm reading.
Yeah. In the chat.
Yeah.
Message.
That was me. Okay.
It's not the top bit.
What?
It's the top sign. It's the top bit of the signed value. So So that what they
This is
haven't
not
said,
how it.
they
This
haven't
is
said
not
the
how it's
top,
implemented.
yeah, they haven't set the top bit. They've set the second from top bit. I presume then so that it's effectively the top bit if you treat it as an int32.
No. You're being misled by documentation here. Message witness TX is not the same thing as message WTX. Message WTX is the in value. This is something else. This is when you're
No, that's
this is
this section is
I-
inventory
I-
vectors. The object type is the type of the IV field.
hang on.
Let me go pull up the.
I promise you this is not how it's implemented.
It looks like how it's implemented to me.
Hang on.
Shall
Okay,
we,
so
shall
it's in
we
protocol diet.
circle back on this?
Yes.
But bear with me. I'll show you. Yeah, here it is.
Wrong one. That should have been all panelists and attendees.
So this is what's defined in BIP 339, and then you're confusing it with this, which is defined in BIP 144.
Right. Okay. Yeah. Okay, so the wiki page is then just not been updated to include.
I don't think it has for BIP 339, which is the bug in the documentation. Which in general you can't trust the Bitcoin documentation. You have to check what they've actually implemented.
Yeah.
Unfortunately. Okay, so I think we're done with that.
Hang on. This is you're looking at the get data implementation though. Is that where we should be?
Oh, it's the same.
It's the same. Right.
There's a doc comment in there that says that half of the values defined they can only occur in get data. Invs always use TX or WTX or block. So they have a combined.
Great.
Yeah, it says get data inv. And they're reusing the namespace for two different things effectively, because in inv messages, this message TX and message WTX are the only valid values, and this message WTX can't happen anywhere else. So they effectively have two completely different enums that are reusing the same values, which is irritating, but that's how it's defined. Yeah, and I think we are better just following what BIP 339 does, because it does map onto Zcash pretty well. Okay, let me just check that published correctly. Yeah, it did.
Yeah. Okay.
I will stop screen sharing.
All right, very good. Anything remaining on that one from anyone?
I realized this was said a lot earlier, but I also wanted to clarify that the authorizing the witness data in blocks can't be modified because the witness data hashes for all of the blocks are committed to in the block header. Yep. So yeah, that's the other part of the security that exists for blocks that doesn't exist in the mempool.
Correct, yes.
I was wondering, are there any other downstream impacts for the transaction ID not committing to the entire data of the transaction? Might it affect exchanges or wallets that assume that there's only one set of data that can possibly correspond to a transaction ID?
I think it possibly does.
It's entirely possible that someone could be making that assumption, but the assumption they're more likely to be making is the one that this fixes, makes canonical, which is that the TXID they see is the only one for the logical transaction they're looking at, not the actual bytes of the transaction.
I think if we document the difference between TXID and TXID properly, and make sure that exchanges are aware of that. Then it's basically the same as in Bitcoin, apart from the length of the WTXID. So they will know about this. They just won't know that it applies to Zcash, and that's what we need to tell them.
Yeah, and the failure case for them, the failure case for them getting that wrong is DOS, not loss of money.
That's also helpful.
Yeah, the current situation is that where TXID is exactly the bytes in the transaction, and then the opposite for case not being fully served is you get in a situation where you can't mine a transaction that you expected to, and you lose funds. So this is inherently safer, even though until we deploy this particulars, there's a potential DOS risk on the net, for wallets and things.
Yeah, I think exchanges that also support Bitcoin are less likely to have made this assumption, because they will have, even if they started before SegWit, they will have had to take account of this for SegWit.
Is there any way that we can catch these kinds of missing network protocol changes earlier? You've probably been asking yourself this question this week.
That's a good question. Yeah, so Strad spotted this one.
It's one that I think had crossed my view a while back, and I had just forgotten to raise, but as was evident to the Bitcoin devs, like it wasn't urgent to fix it because it wasn't a consensus issue. Like this does not need to, this does not quote unquote need to be deployed within Nu5. It is just convenient and inherently better to do so. So identifying these kinds of improvements would be, it would be useful, but in terms of at least the network layer isn't as crucial as making sure that we get the consensus changes right.
I mean, there is a mistake that we could have made, which is to still assume that we could cache invalid transactions by their TXID. I don't think we would have made that mistake, and it would be easy to fix if we did.
Well, because again, if you're caching in that sense, then again, the failure case there is not one of consensus, because it's not affecting how transactions get into blocks. It's just nodes will reject.
Censorship.
Exactly, and that can be fixed outside of network upgrade.
Yeah. Exactly. Yeah, and we would have had until mainnet activation to spot it and fix it if we'd made that mistake.
Yeah.
So I guess this is, oh, sorry, go.
No, I'm sorry. I just saw Addy had a hand up.
Hey, yeah, so there was one use case for the wallet side we are thinking of is during the auto shielding process or a Z2Z transaction, when we broadcast a transaction to the mempool, would there be a way to know which transactions are in the mempool, like querying the light wallet server, some server, knowing and fetching without fetching all the transactions in the mempool, can we query whether my transaction exists in the mempool?
You can't universally query that because mempools are entirely per node. Like mempools are outside of consensus in a sense. So if Light Wallet D were to implement that logic, all you would be able to learn is that the particular node that Light Wallet D is talking to has it in its mempool or not. So that would still probably potentially be useful, but it doesn't give you full guarantees that it actually is the network. The local node could be lying to you, or it could have it in its mempool, but for some reason that hasn't been propagated to the rest of the network.
Or it could be that that transaction will never get mined, either because it can't be because of a double spend or expiry or something else.
Yeah, those ideally will be rejected by the mempool though. So the local node would not, if a light wallet D connected to a local node would not inform you of those.
Yeah, true.
I see. So the preferred approach, would that be that to wait for at least one block confirmation to see that the transaction is in?
Yeah, when you see a transaction in a block, you know it's hit the consensus rules, you know that it's reached through the mempool to at least one miner and has ended up in a block. And one of the improvements that we have, one of the improvements made with the non-malleability changes is that it will be possible for Light Wallet D to provide proofs of inclusion for transactions, and in fact for compact transactions as well. You can prove that like a nullifier that you've been sent as like this note has been spent is included in a particular block header because of the way in which TXIDs will now be constructed. That's not something that's on our get it implemented before Nu5 activates path at the moment, but it's something that the upgrade enables.
Teo, you were interrupted. You were saying something.
Yeah, I guess this seems like more of a usability thing than a consensus breaking thing or a network robustness thing, which is important, but I guess not as important as not as important as losing money. But if we want to grow the network, then people being able to spend money whenever they like very reliably becomes very, very important.
Yeah. And the reason I wanted to get this in as part of the upgrade is that the overall protocol just ends up being simpler if you've always had this rather than having to do it at a later time as in Bitcoin.
Yeah. It would be useful potentially to when we get to a point where, like, for example, the network protocol is better documented, it will be easier to consider how changes to the consensus rules apply to the network documentation as those changes are made. So getting to that point would be very beneficial, and would probably make it easier to spot them, I think.
Oh, I should have resolved the open issue. I'll do that in a separate PR. It's slightly embarrassing that we're having to link to the Bitcoin documentation here, because that's the only documentation of our network protocol, even though it's different.
Yeah, Strad, that was kind of where we were getting to as well, thinking that as we build these things and test them with a different node implementation, we will need much better documentation about what's expected, because otherwise we get to a point where we say, you're doing this thing and we're doing this thing, and obviously they don't match up. What's the best choice here? And as we make those decisions, it would be really good to document them. I think that's also going to impact us as we add a mempool. I think sometime over the next few months, we'll really need to know how it's supposed to work. Or we'll need to know that we can do our own design because it's not consensus critical, but we'll need to know what we need to be compatible with. And there isn't, I don't know if there's good documentation for Bitcoin mempools. I haven't seen anything really in the existing network protocol documentation.
Yeah, I don't think there's a need technically. I think mempools, you can basically do what you want because, as you say, they're completely outside consensus. And it's up to a local node to decide how it wants to handle its own, like, memory usage limits versus, whatever. The trade-off you get there is, so we haven't yet backported upstream's notion of compact blocks, where block propagation only propagates the mempool delta. That is where it becomes more, I think, critical in terms of exactly how the mempools are implemented. But even they're not particularly critical, because all it means is if your particular policy is to reject far more and keep things lower, then when a block comes in, you have to pay more in bandwidth. There's obviously, like, if we don't want something to become pathologically a problem on the network, if a particular kind of transaction ends up being rejected from a majority of nodes where it shouldn't be. But
so all of this documentation should go into zip 204, which is reserved.
What I'd like to do actually is once we're over the back of Nu5 implementation, given you said you were looking to do a mempool in a couple of months' time, it would be good to maybe sit down with some get a couple of open pairings going or something, and collaborate on figuring out what it is that Zcashd does and how that would affect Zebra.
Even just documenting all of the data formats used in the P2P protocol would be a help.
I think we have reasonable documentation for those formats, or they reasonably match Bitcoin. But yes, where there are some places where we know they don't match what Zcashd actually does, either because we've misread the Bitcoin spec or because the improvement proposals don't match up in terms of what's been implemented and what hasn't.
Yeah. Is it, Derry, you said zip 214 was where this was going to live?
Zip 204.
204. So the intention is that becomes a living document describing the network protocol?
Yeah, that's P2P network protocol differences from Bitcoin.
Differences from Bitcoin, or do
we actually,
because that still doesn't give us the Bitcoin bits documented.
Okay, all right. I'll change that to Zcash P2P network protocol.
Rename
it. I'll do that right now.
Is there a similar one for the mempool? Because I think it would be really good for us to explicitly document the rules or the expectations, even if they're minimal. It would be good to have an explicit statement that they're minimal.
Yeah. We could maybe start there rather than trying to get a full zip up. Just getting some documentation into the Zcash book about the Zcashd book about what its behavior currently is, and then we can from there see whether there's interaction that rises to the need of a zip.
So I guess our final question here was, is there anything else that's missing or that would be really, really useful to be in Nu5? Just because we would need to know about it for our planning. I know that's a very open-ended question, but if there's anything,
we're certainly
else
not like hiding anything.
Well,
no. Sorry, I'm not.
I know you're not saying
what
that.
I was implying.
I know you're not saying. I'm just joking.
What I was implying was, is there anything that might vaguely be included that we should think about, given that there's been a few additions over the last few months, which are great and important and really important for simplifying the network protocol, or in the case of unified addresses, for making multiple shielded pools actually usable. So I want to be clear, I'm not objecting to any of these changes. We just, I guess, are fortunate on our side that we haven't done a lot of work on those two things so far. So the impacts have been fairly minimal. But yeah, if there's anything that's going to impact things that we've already written, it'd be great to just, I know that's hard in the middle of a crunch, but
I think that you can expect perhaps that we will discover, one or two more things in the coming couple of weeks. That's probably as precise as we could be for knowing what we don't know.
Remember that we've still got audits to do.
The chances are, unless audits come back with something, there's probably not going to be anything more, I'd say.
not
Yeah,
another
there's
zip.
there's a non-zero probability that there's going to be one or
Yeah.
two more.
I mean,
nodes, but I really hope there isn't.
If we look at the set of changes that we at this point are in the network upgrade or ancillary but being deployed at the same time, then the parts of the protocol that it interacts with, that they interact with, we have transaction formats. That's what interacts with TXD propagation. Well, the non-malleability is what interacts with that. That only affects inv and well, it affects inventory fetching and the corresponding get data logic because you need to fetch those informations. But there's nothing else that pushes transactions around the network outside of a block, and the blocks headers and things aren't altered. So it's unlikely to see anything else affecting that. As far as orchard inclusion, we included sapling and didn't have, we haven't discovered anything. I don't recall discovering anything that when we introduced sapling that caused problems at a network layer beyond what we had already done for like the overwinter upgrade and so on. So I don't anticipate anything for the integration of orchard that we haven't already accounted for, given that sapling was successfully deployed. And then there's nothing else
that's right.
that touches the network layer that I can think of.
Also, for those two zips, we are mainly talking about the wallet layer and the network layer. So we are working outwards, which is a good sign.
Yeah.
Yeah. Okay, that makes sense.
Yeah. And then as far as wallet layer stuff goes, the unified addresses is one address format, and it's clear where that will affect things, and also clear that there's not going to be another address format that needs addressing.
Mm-hmm.
Unless we made some horrible mistake with unified addresses, which I don't think we have. The only thing that I can think of is if it turns out that unified addresses are unusably long. We might want an optimized version, but I think they'll be fine, because I think people are usually use just cut and paste and QR codes, so it doesn't really matter how long they are.
Going forward, I wonder what we can do to not clone Strad's algorithm of, hey, this might affect other pieces of the protocol or of the code base, and I just happen to remember to go look. But in a more systematic way, maybe at the zip level. And I think it was either during our most recent zip meeting or sometime after or whatever, which was like, what does the zip editor process, what does zip0 say about basically trying to discover or enumerate downstream effects of a change? For us, it'll be very like, I'm going to grep my code base a little bit and see if I can like real easily see anything that pops out at me to see if there's anything around changing the transaction ID to be different will affect network messages, in types, stuff like that. But it won't be that easy, because like the thing about the security concerns do matter for mempool, don't matter for mined transactions, etc. It may be worth us trying to systematize this a little bit better earlier in the process, so that when we're still talking about a zip and a change, we can try to find the downstream effects that it may have on a node implementation, and whether they are consensus critical, not consensus critical, but a good idea to wrap them up together with a chunk of work, as opposed to chunking it up into multiple network upgrades, either earlier in the zip process or earlier in the NUP process, so that we're not finding them late. We're finding them as early as we theoretically could.
I think part of the issue is that the writing the circuits for Orchard has been really complicated. So that's taken up a lot of our bandwidth. that
Oh,
we could
sure.
otherwise have been using to find issues like this.
It is also very easy to sort of get into a bit of a silo in terms of looking at the consensus rules. Yeah, in part because like they matter so much, but also because the there's probably an element of it's in the wheelhouse that we're well familiar with. And I think, yeah, taking the time at some point to go through the exercise of
I mean, we should have
systematizing the domains that are downstream of the core consensus rules.
Yeah, we should make time in future upgrades to consider that more thoroughly.
Yeah. Checklists.
Yeah, like that
Checklists are
way,
good.
if we have checklists, if we have sort of a like, make sure that you try to look for these things, it'll help a human who may be busy and may be distracted to be like, oh yeah, like, okay, well, just one of those things may help us or find stuff like this a little earlier rather than later.
I mean, just off the top of my head, drawing a graph of what things in the protocol depend on other things would be useful.
Love it.
Sorry, muted. Deirdre's point about agreeing out grip for things is also nice from a, like that's something I think that it is nice about having a protocol spec that covers like, is as long as it is because you know, it's in there somewhere. And having a protocol spec with a type system that that lets you find things. So it might be something to think about in terms of, yeah, maybe having some sort of core higher level place that these things reference for common terms or symbol names.
Yeah.
Addy, you had your hand up.
Yeah, quick question to Dara. Will the unified address be compatible with the payment request URIs out of the box?
So there's, from a specification level, there's nothing to stop you from putting a unified address in a payment URI, and that will be implemented in. I mean, I'm not sure to what extent we do implement payment URIs in our code. Do we implement them in?
So just considering any edge cases that might exist, if we put in the unified address inside the payment URI structure. Like
What?
There shouldn't be any edge cases.
Okay.
It should just work.
The behavior, so a payment URI conveys a request for payment from the requester to the wallet that is going to fund it. The behavior of it should be as if the person who's receiving the payment URI had typed those fields into their wallet themselves. So if the wallet supports unified addresses like pasting one in to send funds to, then the behavior should be no different to if they receive that UA via a payment request.
Exactly. The algorithm for choosing which of the constituent addresses to send to is identical.
Yeah, so you wouldn't just take the thing in a payment address and just like try and shove it into a transaction builder. It would have to go through the, you know, being parsed like any other address and then go through the UA logic of figuring out how it should be received to.
I mean, we can put a note in zip 321 to that effect. It's kind of obvious, but we can make it explicit.
Okay, thanks.
Okay. All right. Anything else? Any kind of random? While we're just kind of talking generally about Nu5 and progress, before we talk in more detail about the remaining audit schedule, you want to provide an update on the test vectors? We merged quite a few of those over the last couple of weeks.
Yeah, yeah, we have a. I think we've got most of them in there now. There's only the transaction format one is still just needs, I think, one more review, but is otherwise there. And I think everything else, like all the key components and note encryption and stuff has test vectors now.
Okay.
It's probably there might be something that I'm missing, but yeah.
I thought the note encryption had been merged yet. It might have been since I last.
Yeah, it was merged, but I just need to go and tweak the output to actually. There's a couple of things.
Oh, that's right.
The output that's missing.
That other,
yeah, but I'm doing that today.
All right, very good. All right, let me. I'll get my screen back up. And we'll continue. Okay, so the main item to cover here, the same set other than ZIP 239, which we just talked about. A little bit of detail on the remaining audit schedule for Kedit, and I should have put, this is the implementation audit. Both groups have completed their specification audits. The project kickoff for Kedit is the 7th. We'll have a status on the 21st, and then the interim findings on the 1st of July, and then they'll take a week or so and produce a report. NCC is a very similar schedule. They kick off a week later. Status on the 21st, and another status on the 28th, which is kind of the final. And then on July 2nd, they'll kind of have their essentially a draft report ready to take a look at. So that's what we're looking at in terms of remaining audit items. What that looks like, here's kind of the typical Nu5 timeline schedule. Made a little bit of an adjustment here. We had testnet set to activate July 1st, kind of a point in time. As we get closer, obviously, to those times, we kind of look at more of a window. Tior and Deirdre and I were discussing this in general for the NUP for part of the presentation we're working on for ZCon. But we want to make sure that we, take in, as Sean mentioned, anything that comes out of the implementation audits, we want to make sure that we have time to get that into a testnet support release. So we're kind of looking at doing that somewhere roughly toward the end of June with an activation window first half of July, but that's kind of subject to change, just so everyone knows. And ditto on the mainnet activation window. We like to have 3 months in testnet for partner adoption, and in particular for Nu5 is a pretty big upgrade. So we want to make sure we have adequate time for partners and everyone in there. So anyway, that's kind of what we're looking at currently. Any questions at all about the audits?
For the Kedit audit, so they're implementing they're auditing the implementation in Zcashd, the Orchard crate, and the Halo 2 crate. Is the ultra plonk arithmetization and Halo 2 kind of all wrapped up in that?
To be clear, they're treating the design of Halo 2 as a black box because that's being audited by Mary Mallett.
Okay.
So they're assuming that the cryptographic design is correct, but it is in scope to check that the implementation matches that design.
Okay. Okay, thank you.
And any ambiguities or misspecifications as well.
Do we have an update on the Mary Mallett, I guess, security proof of Halo 2? I know that it's been talked about before, but I forget.
Yeah, so we have a PR up on the Halo 2 repo to add the proof to the book. It's not finished and it's not merged yet, but once it's merged, that's what Mary's going to look at. We actually have some changes we have to make to the Halo 2 protocol implementation before Kedit starts looking at it, before we do a code freeze to match what Mary has been analyzing. So because this is actually kind of working out pretty good in terms of the coordination between the different audits, because we don't want Mary looking at a protocol design that ends up not being what Kedit's actually auditing the implementation of. They have to match. So we have to get a code freeze in the coming days, and then we have weeks of more time for Mary to actually look at over the proof and the protocol description changes that coincide with that. So there's that's the current status of that. So actually the timings are working out pretty good.
Awesome. I look forward to reading. Well, I guess I can read the PR, but I look forward to all the LaTeX.
Yep. All right. Yep. Okay, other questions at all about the audits or anything? Because that was pretty much all we had today, which gets us a few minutes back. Anyone have any other, anything else at all? Open items, Nu5 related or not?
I'd wanted to ask, because I've seen, in recent, in the last week or so, maybe the last 2 weeks, I've been seeing in my GitHub notifications mentions of various parts of Libra Zcash in the Zebra feeds. So I was wanting to get a, just check up on what it is that you're actually going to be pulling in, so that it's on our radar.
Sure. So at the moment, we know that we're going to be pulling in the Zcash history crate, both for the both from Canopy activation for the pre-Nu5 format, and then after we add Orchard, we'll want to use that as well after you merge your Orchard PR. We're also using, I don't know what part of the crate, but whatever part calculates non-malleable transaction IDs and authorizing data IDs for transaction V5. I think we might want to use your Zcash for transaction V4 as well, but we're not sure. I can't remember what decision we made there. We found some bugs in our Zcash by comparing it with yours.
Yes.
Cool. And I don't think, we want to use, this is not Libra Zcash, but we want to use the circuits out of Orchard because we don't want to write those ourselves for obvious reasons.
When we need to.
When we need to.
If we can pull out if we can depend on the verification key for the actions in the Orchard crate, we'll just do that. If we probably just for verification, when we get to the client, when we get to our wallet, we'll probably
decide
be
what
pulling,
to do then.
we'll probably be pulling in a lot. Basically everything that's like a proof in a circuit is like, we're just not even going there.
So we'll be providing like an API, obviously, to verify the proof.
Okay, cool.
Yeah, that's already in there, I think.
Yeah,
it's
in Halo 2, and then the Orchard crate does the mashing of different types into different types.
Yeah, there's a verification key, wherever it is, type in the Orchard crate right now, and then there's a proof object. The Halo 2 bundle, sorry, the Orchard bundle proof object type. The opaque bytes it contains. That has a verify function, which currently is just stubbed out. But that's the primary interface that you'd be able to use. So my guess is you would just deserialize, load in the bytes from wherever you're sourcing them from, and then
call it.
And I think the verification key actually will probably embed that into the code. So
I think so.
Nice.
And then we'll run tests that generate it and test to make sure it's consistent, but it'll be probably embedded in the code. That way you don't have to download a file or something.
Yes.
Yeah, likely to be small enough. Proving key will probably just generate at startup.
That was what my intuition was, that it was the size was not going to be an issue the same way that the sapling parameters were.
So in terms of that, the whole difference between the parameter, the reason why we distribute parameters is because of the trusted setup. If there's no trusted setup, then you can deterministically compute them locally. So we won't, there might be clients that are capable of making transactions will maybe want to create the parameters locally for proving and then store them and cache them. That might be something that we'll have to think of an API for. I haven't really thought of that yet, but currently,
I don't know how long does it take to generate the parameters, the proving key?
Not very long, but we should.
Not very long on our machines.
Well,
you might want to cache it on mobile platform or something.
Yeah, it's certainly it's perfectly fine to generate them on a mobile. It's just you may not want to be doing them every time it loads into memory.
Yeah.
Which could be multiple times a session, depending on what the OS wants to do to you.
Doing it
Exactly.
the very first time, every time might be nice, but definitely not the every time you load up from there on.
Hmm.
Could also be done as we sort of do with the checkpoints, right? Which is that they are actually embedded into the code of the mobile wallet SDK.
Yeah. If the developers want to pay the size and the SDK size, given they have to download the SDK anyway, then yeah. I mean, we never did that with Zcashd for the sapling parameters. But in theory, we could have hard coded the binary, 50 megabytes of data into that. We just never had the logic to do so because we weren't going to do that with the Sprout parameters when they were 2 gigabytes.
I guess to finish answering your question, we don't know about anything yet, but we're actively looking for things where we can reuse work rather than re-implementing things ourselves, just because it's less risky and there isn't a lot of value add for us because particularly when there's nothing to parallelize, it's just easier to reuse code. It's very different for I think the rest of our verification pipeline where we wanted it to be very parallel. But yeah, if there's anything we're doing, particularly as we get much closer to the state where we have all of the blocks and they have to be in order, then those are the pieces that we're keen to reuse.
Cool. All right, very good. Okay, I guess we're done then, unless again, if there's anything else anyone wants to bring up. Okay, doesn't look like it. Well, look, everyone have a good rest.
Oh, sorry, we wanted to just mention ZCon2 Life.
Right, yes.
So next week, the foundation is running ZCon2 from the 8th to the 9th of June. I can paste a link in the chat. Yeah, or if you're in my time zone, it's the 9th to the 10th of June. But for most of the people, it's the 8th and 9th of June. And yeah, please come along, please register, please pick through the sessions and see which ones you'd like to come to. I think a lot of people on this call will be presenting.
Mm-hmm. Gonna be fun.
I think so. It'll be my first ZCon, so virtual. Yeah. So I'm hoping in 2022 that it's somewhere really cool. I've heard of the really cool ones. So yeah. But definitely a lot of good content, a really good schedule, I think.
I'm still hankering to go to Peru.
I know that was going to work out really well. Yep. That was that Lima?
Yes.
Right? Yes. Okay, good. All right, very good. Well, look, everyone have a good Friday, good weekend, and we'll catch up in online Discord, R&D Discord. But yeah, so let us know anything comes up, between now and the next Arborist call. We'll keep everyone updated on progress and audits and things of that nature.
Cool.
Cheers.
See you, everyone.
Take care. All right, bye.
Yeah.